All right, let's do one more example related to taking the derivative of an implicit equation. First thing to notice, this equation is implicit. And why is it implicit? It's not of the form y equals something. Certainly not, right? Okay, now, how are we going to go about taking the derivative? We're going to take, every time we take the derivative of y, tack on dy. Every time we take the derivative of x, tack on dx. Now, here's the first thing to notice. This first term that we see here is a product. It is a product of x and y squared. And in order to take a product, we're going to have to use the product rule. So since what is on the left-hand side is a product, we're going to need u prime v plus u v prime. So let's think about this. First, u prime. We take the derivative of our x, that is 1, then we tack on our y squared. But here's the thing to think about. We took a derivative of our first term. We took a derivative of an x term, so we've got to tack on a dx. Next, the plus sign, and now we need the u v prime. U is a carbon copy of x. V prime is the derivative of y squared. The derivative of y squared is 2y, but since we took a derivative with respect to y, we're going to have to tack on a dy. Product rule, when we took the derivative with respect to x, tack on a dx. When we take the derivative of y, tack on a dy. Now next, the derivative of 4 is 0, that drops out, no sweat. The derivative of x squared is 2x. Since we took the derivative with respect to x, tack on a dx. And now finally, we've got x times y. X times y, that's a product. In order to take the derivative of a product, we've got to use the product rule. And we know the product rule is u prime v plus u v prime. So let us employ that derivative rule to this product. So what are we going to get? We've got the plus sign here, and then what's going to remain for our product? U prime, that's the derivative of the first. The derivative of x is 1. A carbon copy of the second, that's y. But what derivative did we take here? We took an x derivative, so we're going to tack on a dx. And then plus u, which is just a carbon copy of the first. V prime, that's the derivative of y, which is 1. Since we took a derivative with respect to y, we tack on a dy. Okay, now, we've taken all of our derivatives. Now it's an algebraic rearrangement. We've got to put all our dx terms on one side, all our dy terms on the other. So let's try to get our dx terms on the left. So we've already got one dx term over here. We need this 2x dx on the other side. So let's subtract 2x dx from both sides. We need this y dx term on both sides too, or excuse me, on the left-hand side. So let's subtract a y dx from both sides also. So when we subtract those dx terms, we'll have the y squared dx minus the 2x dx minus the y dx on the left-hand side. But now here's the thing, we want all our dy terms on the right. So in particular, this x times 2y dy has to be brought to the other side. So let's subtract the 2xy dy. I'm writing it as 2xy just to rearrange it rather than saying x times 2 times y. Let's just say 2xy, it's stated easier. But now we subtract that from both sides. So on the right-hand side, we still had the x dy term that was left over on that right-hand side, but now we are subtracting 2xy dy. With all of our dx terms on one side and all of our dy terms on the other, we can factor out the dx on the one side. The dx was multiplied by a y squared, a minus 2x, and a minus y. We can also factor out all the dy terms on the other side. That's going to be an x minus 2xy. And now we've got dx and dy by themselves, almost a dy over dx expression. How can we get a dy over dx expression? Let's get the dy by itself by dividing both sides by x minus 2y. Got to do the same thing to both sides in order to keep the equation valid. And well, what do we get? We get y squared minus 2x minus y over x minus 2xy. This is all multiplied by dx, which is still there on the left-hand side. And on the right-hand side, the factors cancel and got the dy by itself. And you say, man, we're really close, right? Because we got the dy by itself, we just need the dx. How are we going to get the dx over there? We're going to divide the left-hand side by dx and the right-hand side by dx. The dx's cancel on the left, and what do we get? We get y squared minus 2x minus y over x minus 2xy, and on the right-hand side, dy over dx. And that is a derivative of a function that was implicitly stated. The original expression of the function, key difference between this problem and previous problems, the original expression of the problem had a product and another product. And guess what? Anytime you see a product in a function and you need to take the derivative, you got to use the product rule. And so we use the product rule in order to take the derivative. Anytime we took the derivative of an x term, we tacked on a dx. Anytime we took the derivative of a y term, we tacked on a dy. All the dx terms to one side, all the dy terms to the other. Factor out the dx and dy, and then rearrange to where you get the dy by itself and the dx underneath, and you've got a derivative.